Hello everybody. Today we're going to start into the second section of our unit. We're going to be using properties of roots and exponents, but today we're just going to focus on the exponent part of this. You should have a little graphic organizer or foldable that we made and something to write with in a calculator, of course. So this is what that little foldable should look like, and take a minute if you didn't do so already to write your little headings in there on how we're going to organize this. We're going to be using properties of roots and exponents to simplify an expression. Underneath that is three subcategories. We're going to simplify with exponents, we're going to simplify radicals, and we're going to use some radical operations. So those go on the little tabs. Today our focus is going to be just this part, simplifying exponents. So when you open up your foldable there, open up that first flap, you'll see the simplifying exponents on the bottom of that page. That's where we're going to be taking our notes today. So in order to simplify exponents, we need to remember back to rules of exponents. These are the basic ones, okay? Don't write this part down in your notes. You already should know this. X to the third times x to the fifth, that would be when we add those exponents, making x to the eighth. This would be when we multiply those exponents, making x to the 15th. Two things in there, a product, make sure you give the exponent to both. What if we have division? We'd subtract those powers. What if we have a fraction? We'd just make sure that both the numerator and the denominator get the powers they need. And then what if we have a negative exponent? He just moves to the bottom to become positive. These are the rules that we have been summarizing over the last few days. So what those properties of exponents, what are they? And then now we're going to take it to the next level. We're going to be simplifying our exponents, but those exponents are going to be fractions. So this is what your foldable looks like when you open it up. Inside there, let's write at the very top how. We're going to use our rules of exponents to do this. The fact that there are fractions do not need to, don't be scared, okay? Don't be worried. We're still going to use the basic rules that we know. Inside this little foldable, we're going to write six examples. So divide the top part there into 3 squares and divide the bottom part there into 3 squares, and we're going to write an example in each one. This is going to be the first one, second one, third one, fourth one, fifth one, and sixth one, and I wrote them on the bottom of the squares. You could write them on the top if you want to, but that's where our 6 examples are going to go today. So your first 2 examples, so this is square 1 and square 2. Let's write these in there and leave some room to write some work, okay? Because these just don't, get figured out too quickly here. We are going to be simplifying using those rules of exponents that we are used to. So 1 and 2 need to get written in your notes, and then we'll take a look here at number 1. Number 1 has 2 to the 3 halves times 2 to the 5 fourths. Because the 2's are the same base, let's think about the rule that we would do. What would we do with those 2 exponents? That's similar to what if you have x squared times x to the third. You would add those exponents. So in our case, we're going to do the same thing. We're going to add those exponents. So it's going to become 2 to the 3 halves plus 5 fourths up there. Now if I have to add 2 fractions, I need to make sure that they have common denominators if I'm going to do that by hand, or I need to make sure I know how to add fractions in a calculator. Whatever you got, whatever you need to do, but you need to add those 2 fractions together. So I'm going to make common denominators here. I'm going to change my 3 halves into fourths. So I'm going to multiply the top and bottom by 2 here, and my 3 halves becomes 6 fourths. So I have 6 fourths plus 5 fourths. My final answer becomes 2 to the 11 fourths power. Okay, that's the simplified answer that we want. And now let's look at the second one. Well, what if we have a power onto a power here? This is when we multiply those exponents. So this situation is going to look like 4 to the 2/6 times 3/4. Now when you multiply fractions, you don't need common denominators. So I can just multiply straight across here. I'd have 4 to the 6/24. You can't leave 6/24. That's just not right. We need to simplify that. It becomes 4 to the 1/4. And again, if you're using your fraction buttons on your calculator to add or subtract or multiply fractions, that's fine. Just make sure your final fraction exponent matches what we have here. So as a reminder, on the bottom of those two squares, let's write down what we did. We added the exponents here on this first example. So maybe somewhere in that box, write a little reminder. We had 2 to the 11/4 as our final answer. We added the exponents, and then what did we do here on our second example when we ended up with 4 to the 1/4 power? That's when we multiplied those exponents. So in your little box on your notes, write that little shortcut in there to remind yourself what it is that you did. Okay, let's take a look at number 3 and number 4. What are we going to do when we have a product or two things, different bases inside here? We make sure that we give the power to everybody, okay? So this becomes 5. Now, since the 5 had a 1/3 power and I'm going to put a 3 power on it, I multiply those powers. 1/3 times 3 is a 1. And then multiplying those powers, 7. And then 1/4 times 3 is 3/4. So this becomes 5 times 7 to the 3/4 power. No, you cannot multiply the 5 times the 7 and make that a 35. That's a 7 to the 3/4 power. Okay, that's not your regular standard 7 there. So 5 times 7 to the 3/4 power is my final answer. Let's summarize that square right away here. What did we do? We remembered to give the power to everything. And if it already had a power, we had to multiply them, just like the rule says. Okay, let's look at the fourth box here on your notes. That would be in the next row. We have 8 to the 9/7 divided by 8 to the 1/2. If you remember the rule here, when we have division, our little summary rule is we will subtract the exponents. So my answer will be 8 to whatever I get when I take 9/7 minus 1/2. Okay, so 9/7 minus 1/2. Either go to your calculator and you type that in, or you'd make common denominators. Let's see, 9/7 is 18/14. If I multiply by 2 there, and then my 1/2 is 7/14. So 18/14 minus 7/14 makes 11/14. So my 8 would be to the 11/14 power. So reminding ourselves that we have to subtract those exponents even if they're fractions. And the last two. Again, if we have a fraction inside, we go ahead and make sure that we give the power to everything. Okay, top and bottom of that fraction. So if I was going to simplify this one, I'd say this is x to the 1/3 over 27 to the 1/3. And there is even one more step that we should do to simplify this. Because we remember that a 1/3 power is the same thing as a cube root, and we recognize that 27 is a perfect cube, we should take this one step further and make him x to the 1/3 over 3, because the cube root of 27 is 3. Okay, there's my final answer for the fifth box. And then the sixth one here deals with a negative exponent. So negative exponent, what are we going to do? Anything with a negative exponent needs to move. So this example that you should have in your notes, let's rewrite what he would look like if this base and his exponent move to the top of the fraction. So the top of the fraction would still have 4 to the 7/2, but now I would put another 4 up there, and now he would have a positive 3/2 power when he moves to the top of the fraction. And now that they're side by side up there, this is when I add those exponents, making it 4 to the 10/2. 7/2 plus 3/2 is 10/2, which is the same thing as 4 to the 5th. And if you wanted to keep that going even one more step, 4 to the 5th power is the same thing as 1024. So be careful, our little summary rule there. Still, when you're dealing with negative exponents, we move the base that has the negative power to the top. Notice when we moved him to the top, this 3/2 fraction still stayed 3 over 2. It didn't flip over, but its negative sign was lost there. Okay, we lose the negative when we move him to the top. Very lovely. So those are our summary notes on how to deal with these exponents, and we'll be working on this in days to come. Thank you.